Now that we have defined a complex number in this Cartesian form, the next thing that we want to do is to discuss how we manipulate these numbers. Now the easy way to tell ourselves how to do this is to tell ourselves that they follow similar algebraic rules for real numbers. Now we look at an example to illustrate all this. If we say z1 is 1 plus 2i and z2 is 3 minus 4i, and we say that we want to add them up, then what we really want to do is to add the real parts together and the imaginary parts together. Meaning, the real part 1 add the real part 3 gives you 4. The imaginary part 2i add to the minus 4i will give you minus 2i. And if we want to subtract z2 from z1, then what we want to do is to subtract the real parts and the imaginary parts separately. Meaning 1 minus 3, 2i minus minus 4. So 1 minus 3 gives you minus 2, 2i minus minus 4 gives you 6i. For multiplication, if we want to multiply z1 with z2, then what we do is we follow again the same rules we have when we deal with real numbers. Meaning, when we multiply 1 plus 2i with 3 minus 4i, we do this 1 times 3, 1 times minus 4, 2i times 3, and 2i times minus 4. So we have 3 minus 4i plus 6i minus 8i squared. Now, the thing to remember here is, when we have I square, we must tell ourselves that I square is minus 1. So this piece here can be rewritten as 8 times minus 1. And so I will have 3 minus 8 times minus 1 gives me 11, and 2i plus 2i. Now, divisions of complex numbers are a little bit more tricky. In our example, if I want to divide z1 with z2, meaning 1 plus 2i, I want to divide it by 3 minus 4i, I have to tell myself that my answer has got to look like this. X plus iy, where the I is at the top. Now, this is no good here because we see the I at the denominator. Now, there's a neat trick that we can use to move the I from the bottom to the top. Now, this involves looking at the number below. Now, the number below is 3 minus 4i. Now, if I multiply the complex number, okay, by the same number, but I reverse the sign in front of the imaginary part, then I realize that I can always get rid of the I below. Let's do this separately. If I have this piece, and I look at the denominator alone, and then what happens when I multiply it out will be 9 plus 12i minus 12i minus 4i whole thing square. And you realize that the 12i and the minus 12i cancels each other out. Then I get the 9 minus 4 square is 16, I square is minus 1. So I end up with 25. So in the end, you can see that the denominator no longer has a I, and the answer is just minus 5 divided by 25 plus 10 divided by 25, and then this is my answer.